How are you, my curious fellows? 2,400 years ago, a philosopher, Democritus, lived in the ancient Greek city of Abdera. Abdera was popular for fun and jokes, as sometimes happen that a place or people are associated with humor. People always smile when they hear of a certain place or people. Abdera had the same funny side for the Greek people. Even if you look at Democritus's statues, his mouth is open in a funny way. Democritus was unpopular among his contemporaries. Even Plato didn't like him. His strict criticism had made other philosophers hate him. But this unpopular philosopher made a wonderful discovery 2,400 years ago. At that time, philosophers were debating about the smallest particle of the matter. They wanted to understand this smallest particle. Plato and other philosophers had a theory regarding this smallest particle. They thought everything was made up of four elements: fire, water, air, and soil. In pre-Roman times, philosophers and well-read people were rare. They believed in the theory of four elements. They thought that the man was made of clay and water. But Democritus observed that a thing could only be broken to a certain extent. The last particle couldn't be broken further, and this last particle was neither water nor soil, fire, or wind. That last particle looks same like the original matter. For example, if you cut any fruit, even its smallest particle will be sweet. The smallest particle of the stone would be just like stone. So in everything he discovered, the smallest particle resembled the original one. So he concluded that there was a limit to everything, whence it couldn't be broken further, no more breaking. So Democritus concluded that the theory of four elements, fire, water, air, and soil, was wrong. Actually, everything was made of an indivisible smallest particle. It was an indivisible particle. In Greek, indivisible was called atomos. So Democritus also named his unseen indivisible discovery as atomos. He declared that everything in the universe was made of this indivisible particle called atomos, atom. Everything had a different set of atoms. That's why everything looked different from others. He speculated that soft things like food items had soft atoms while stones or iron had hard atoms. He also made sketches of these atoms and showed it to his students. All this happened 2,400 years ago. He also explained that everything that was easy to break had more gaps between its atoms. That's why it was easy to break that thing. Now, this was a very simple but genius idea. So now we can conclude that when a fact is proven by observation and repeated tests, its explanation is called theory. So Democritus was the first person to present the atomic theory. You may call it a hypothesis because it was fully discovered and proven much later. But the most intelligent contemporaries of Democritus rejected his theory. Plato was among those people. Plato hated Democritus so much, he even wanted to burn his books. Plato believed in the old theory of four elements: fire, water, soil, and air. For the next 2,200 years, Plato's views prevailed. No one believed in Democritus. However, his books were translated from Greece to Arabic and preserved by the Abbasid dynasty. Then came the year of 1808 CE. An English chemist, John Dalton, discovered a wonderful fact while experimenting on gases. He was mixing gases and chemical compounds to make new mixtures or compounds. He noted that the weight of each element in a new mixture was the same. This fact proved that everything was made of the particles of same shape and weight. These particles maintained their weight in new mixtures. He also observed that things didn't mix with each other. Actually, their particles mixed. But these smallest particles, even after mixing, remain the same. Because if they did change, then the new mixture should be a different thing with a new weight. But that wasn't the case. So John Dalton continued his experiments and further refined Democritus's atomic model. He said that everything was made of elements. These elements were different from each other because their particles, atoms, were different. He said that atoms could not be broken, remade, or given a new weight. This idea of Democritus and John Dalton, which is fact-based, is called atomic theory. Although this theory was refined over time, it is now possible to break an atom, which leads to a nuclear explosion. Then electrons, protons, and neutrons were also discovered inside the atom. But the basic idea, the atomic theory, further strengthened. Now it is a known fact that everything is made of atoms and not air, water, fire, and soil. Even air, water, fire, and soil are made of atoms or reflect atomic energy. These things don't create anything. This theory is true at the moment because we can see atoms with an electron microscope. But this theory was accepted before the invention of electron microscope. This atomic theory made other discoveries possible in chemical reactions and physics. So any explanation of the facts that is proven by experiments again and again is called theory in the field of science. Theory explains scientific laws and models. That's why the atomic theory is a scientific theory. It is no dream or assumption. Let's take another example. There was a scientific consensus until 1912 that the Earth's structure and shape was the same since the beginning. It was believed that when the Earth was separated from the Sun 4 billion years ago, and then it cooled down, its shape were the same since then. According to this theory, the 7 continents had existed in the same shape for billions of years. But in 1912, the German geophysicist Alfred Wegener observed some startling facts. He studied the maps of the continents of Africa and America, Australia, Tasmania, and parts of New Zealand. He also studied the geography of Sri Lanka near India, Madagascar, and Africa, the mountain ranges of Europe and America. He found deep resemblance among them. Even if you study these maps, you will also discover this wonderful fact. This geography points out that all these areas were actually one large continent a long time ago. This was the first step toward discovering new facts. Then Alfred Wegener started collecting more proofs in favor of his observation. Poor Alfred Wegener spent his life traveling from one continent to the other in harsh weather conditions. His efforts bore fruit. He found a lot of evidence. For example, he found an undeniable proof that Africa and Americas were once the same continent. The first proof was that they both looked like the pieces of a same puzzle. Then he also found fossils of the same long-tailed reptile in both areas. These fossils belong to a reptile Mesosaurus that existed 200 to 300 million years ago. Mesosaurus was a 3 feet long freshwater reptile that crawled on 2 feet and looked like a crocodile. This reptile is now extinct, but its freshwater origin helped Alfred a great deal. Mesosaurus fossils were discovered near and inside the freshwater sources. Its body structure also proved that it was a freshwater animal. Surprisingly, the fossils of the same animal were also discovered across the Atlantic Ocean in eastern America, 4,000 kilometers from Africa. These fossils were as old as the fossils of Mesosaurus found in Africa. These were also 200 to 300 million years old. Now it is a question, how do we measure the age of a fossil? We will explain the answer in detail in these vlogs, and you will also learn about radiocarbon dating. You will learn how does radiocarbon dating work, and what are the other methods like it. Just keep watching this series. But let's complete this story first. The discovery of the fossils of the same shape and age in Western Africa and Eastern America clarified one fact. It proved that it was impossible for this animal to cross 4,000 km of Atlantic's saltwater to enter the other continent, because these reptiles could only survive in freshwater and not the ocean. You will never find a river fish in a sea. Since it was impossible for the animal to swim across the ocean, it proved that both these places were once united. It was possible that Africa and Americas were once attached to each other. Only in that case it was possible for Mesosaurus to exist in both the continents, and that's why its fossils were found in both places. Even a 4,000 km gap between them couldn't erase the evidence. Alfred Wegener also observed the rocks of the American and European mountain ranges. He noticed that the rocks on both sides were strikingly similar. Even the fossils found later here were also similar, and 200 to 300 million years old. Logically, they should be one great landmass at that time. Similarly, the rocks of Africa and Americas were also once attached to each other. Now, Wegener had enough evidence to present his own theory, so he presented the continental drift theory. He declared that all continents were once one great landmass. There was a one great continent, but its pieces slowly drifted away from each other. These pieces of land are still moving. He named this great landmass Pangaea. He also predicted that scientists would soon discover similar evidence around the world. He said that there should be the same evidence in all the areas which were once part of the same landmass. Only then this puzzle would be solved. This remarkable theory shocked the scientific community. It was so strange. Thought Alfred had fulfilled all the requirements of the theory, yet he was severely criticized. This was quite logical. Alfred already knew that, because scientific are even more rigid in rejecting new theories than religious groups. because they face tough competition with each other. Therefore, scientific communities only recognize a discovery when it is proven beyond doubt. But when something is proven, everyone accepts it. Everyone accepts it. However, they all try to take credit. So Wagner's continental drift theory was also rejected and ridiculed. The scientific community rejected it as a childish theory. They claimed that it was totally irrational and nonsense to believe that a whole continent was moving. Alfred Wagner died before getting any recognition. But after this death, more evidence emerged to prove his theory. Here is an interesting fact. In World War II, nuclear attacks on Hiroshima and Nagasaki started a nuclear race. Many countries, including the United States and the Soviet Union, started testing nuclear weapons. Now it was necessary to install a system to monitor the nuclear activities of rival countries. So the superpowers installed seismometers at secret locations for this purpose. These seismometers were to record evidence of nuclear tests. But these seismometers made an extraordinary discovery. They proved Alfred Wagner right. These seismometers recorded earthquakes and the movement of the Earth's plates. They recorded every underground movement, regardless of its cause. So through seismometers, humans discovered underground moving plates which carried continents over them. This discovery was made 30 years after Alfred's death. A big hand for Alfred Wagner. These moving plates were called tectonic plates. Then there was more evidence that didn't need any scientific apparatus for verification. This evidence is visible to all. The greatest proof is the Great Rift Valley of Africa. Two African plates, the Somali and the Namibian plates, are drifting away from each other. The valley, including Ethiopia, Kenya, Mozambique, and Malawi, has millions of years old lakes. Now we also have so much irrefutable evidence from magnetic field measuring instruments and satellites. Now we can make predictions about earthquakes, tsunamis, and mountains. So Alfred's continental drift theory is now accepted, but with one minor change. Wagner had discovered that the continents drift, but he couldn't discover the cause and the mechanism. Alfred thought the continents moved because of the motion of the Earth. He thought that when the Earth moves, the plates on it move too. But he was wrong. Now we know that continental drifting is not due to the motion of the Earth. Rather, it is due to the movement of the large tectonic plates. This movement is called plate tectonics. With a little correction, Alfred's continental drift theory is now a fact. Not only Alfred's supercontinent Pangaea is a fact, but scientists also believe in many more Pangaeas. In over 4.5 billion years since the creation of the Earth, many such Pangaeas were created and broken. This process will continue in the future. It's happening even today. The Himalayas was created after the Indian plate collided with the Eurasian plate. Another Himalaya is likely to emerge between Africa and Europe. The Mediterranean Sea, the world's busiest sea, will disappear someday because the tectonic plates of Africa and Europe are moving closer by 1 inch each year. If you visit this place 50 million years from now for vacations, you will find no sea here. Instead, you will need warm clothes because the new Himalayas will replace the Mediterranean Sea. The Asian Himalayas will disappear. Africa and Europe will be joined together to create a new continent. We have understood all this because of a single theory. Despite all these facts, continental drift is a theory, a scientific theory that was formulated by observation and is now a recognized fact. Similarly, today no one denies Newton's theory of gravity. Newton presented a theory in 1665 that every body in the universe pulled other objects towards itself, and the pulling force was measured by its mass and distance. The Einstein further clarified the reason behind the gravitational force. According to Einstein, the space-time curve causes gravity. The discovery of Neptune, the 8th planet of the solar system, also proved Newton's theory. Before that, it was impossible to see Neptune even with a telescope, because its nearby Uranus planet was moving in a way that was only possible in case of a large body near it. Otherwise, Uranus's movement was against Newton's theory. We have shown you the discovery of the planet Neptune in our Cool Canet series. So a theory helped to discover a planet 4 times the size of the Earth in 1849. It happened when it was not possible to discover it with a telescope. Today, the GPS system that we use in our vehicles works because of this theory. It wasn't possible without Einstein's general theory of relativity. Finding locations and map sharing is possible with the help of satellites. These satellites work according to Einstein's theory of relativity. It is called a theory because of its practical usage, supporting evidence and lack of contradictory evidence. It has a scientific theory status. The purpose of this video was to explain that a theory is not somebody's assumption or dream. Rather, an explanation of the facts with evidence is called a scientific theory. A scientific theory can always be verified, it has no evidence against it, and its predictions become true. The world-known fact that the Earth revolves around the Sun is also a theory, heliocentric theory. Before that, geocentric theory dominated the scientific approach for 2,000 years. This theory says that the Earth is the center of the universe. The Sun, Moon, and stars revolve around it in 7 circles. Because of Egyptian scientist Ptolemy, these 7 circles were considered 7 skies. But this theory could not properly explain the movement of planets, especially Jupiter and Mars. It was hard to predict their positions according to this theory. That's why people attributed the wrong movement of the planets to gods and goddesses, even thought it their destiny. Geocentric theory failed because of contrary evidence and wrong predictions. It was rejected and replaced by the heliocentric theory of Polish scientist Copernicus. Heliocentric theory said that the Sun was the center of our solar system, and the Earth and other planets circled it. This theory explained the movement of the planets, and correct predictions were possible. Positons of planets and stars were justified. Satellites sent towards the Moon and Mars work under the same theory. Perfect launching of these satellites is possible because we can predict the actual position of the Moon and Mars. That's why these satellites reach their destinations on time. That's why geocentric theory is now rejected. The heliocentric theory is accepted because it is a practical reality. So friends, studying facts and scientific laws and explaining them is known as theory and not the imagination. Just like all these theories, Darwin's theory of evolution by natural selection is also a scientific theory. But what evidence did Darwin present for his theory of evolution by natural selection? What were his predictions? Is there a single evidence in 160 years that could prove Darwin wrong? Are monkeys our ancestors? We will talk about all this in the next vlog.